So the next example, we have this circuit. So the switch has been in position A for a very long time. So at t equals to 0, the switch moves instantaneously to position B. So find VO of t for t greater than 0. So at t less than 0, our circuit is at steady state. So at t less than 0, we have this circuit. Our VO 0 minus, which is equal to VO at 0 plus. You can get the value of VO at 0 plus or 0 minus by using VDT. We have 4 over 5 times 7.5. So we have 6 volts. Then our IL of 0 minus equal to IL of 0 plus. Since the circuit right here has no independent source, so our IL of 0 minus is equivalent to 0. Now analyzing the circuit at t greater than 0, we have this circuit. So our circuit is not classified as a simple series RLC or parallel circuit. So we need to solve for the expression for V of t. We can solve the expression for V of t using nodal analysis. We have A, B, and we have our reference. So applying KCL at supernode, we have the supernode of AB. We have IC, IL plus VB over 24K plus VB over 40K equal to 0. And write this as IC plus IL plus 1 over 15K VB equal to 0. Take note for IC equal to C dVO dt, since the capacitor and inductor are parallel. So IC can be expressed as C dVO dt if this is IC. Then VO can also be expressed as L di L per dt. Or our IL can be expressed as 1 over L derivative of VO dt plus initial value IO. So using these equations, we have C dVO dt plus 1 over L derivative of integral of VO dt plus 1 over 15K VB equals to 0. Now looking at the circuit, our VB by Ohm's law, where VB is just equivalent to negative 24K I phi. And looking at the supernode, our dependent source 16K I phi just equivalent to VB minus VO. So our 16K I phi equivalent to VB minus VO. So substituting the value of VB, we have 16K I phi equals to negative 54K I phi minus VO. So our VO is equal to negative 40K I phi, or our I phi expressed in terms of VO negative 1 over 40k VO. So our VB can be expressed as our VB is equal to 0.6 VO. Substituting the value of VB to this equation, we have C dVO dt plus 1 over L integral of VO dt plus 40 micro VO equals to 0. Now deriving both sides of the equation and then dividing the equation by C, we have, so our characteristic equation is S squared plus 10ks plus 16m. So our roots S1 and S2 equal to negative 2000 and negative 8000. Our natural response is VO of t equal to AE to the negative 2kt plus B e to the negative 8kt. We have VO t equals to AE to the negative 2kt plus BE to the negative 8kt. Solving for the values of A and B, again, we need the initial conditions. So we need VO of 0 and then dVO dt at 0. So VO of 0 minus is just 6 volts. We have this value. We need to get dVO dt 0 plus. So our VB at 0 plus is equivalent to 0.6 times VO of 0 plus, which is 6 volts. So this is equivalent to 3 volts. Now looking at this equation, for IC of 0 plus is equivalent to negative IL of 0 plus minus 1 over 15k times VB of 0 plus. So IL of 0 plus is 0, then VB of 0 plus is 3.6. So our IC of 0 plus is equal to negative 240 microamperes. Now using this equation, our IC at 0 plus is equal to T times dV dt at 0 plus. So our dV dt at 0 plus is equivalent to IC of 0 plus over C, which is equivalent to negative 60k volts per second. We have now our initial conditions. So at t equals to 0, this equation becomes 6 equals to A plus B. Equation number 1. So for equation number 2, we have dVO dt equal to negative 2k AE to the negative 2kt minus 8k B times e to the 8kt. So at t equals to 0, we have negative 60k equal to negative 2ka minus 8k B. We have equation number 2. Using these two equations, our A is equal to negative 2, or B is equal to 8. Our our response is negative 2 e to the negative 2kt plus 8 e to the negative 8kt times u of t volts. So another solution is to get the Thevenin equivalent of this circuit. So this is the right side of the circuit. Moving for VTH, since this is a dependent source, our VTH is just equal to 0. Now solving for our RTH, we can inject a voltage source, value of V, and we have I, where our RTH is equivalent to V over I. Applying KCL at this node, KCL at node A, we have negative I plus VA over 24K plus VA over 40K equals to 0. Our VA is equivalent to 15K I. Take note that our VA can be expressed in terms of I phi equivalent to negative 24K I phi. So using Ohm's law. So substituting this value of VA to this equation, we have 15K I equals to negative 24K I phi. Our I phi in terms of I is just 0.625 I. So next is need to apply KVL at this loop. KVL at loop 1, we have negative V minus 16K I phi plus VA equals to 0. So substituting the value of I phi and VA, we have becomes negative V plus 25KI equals to 0. So our V over I is equal to RTH, that's equivalent to 25 kilo ohms. So going back to the original circuit, so we have simple parallel RLC circuit. So this is 55K, 15.625. We have 4 nano plus minus VO. So our alpha is 1 over 2RC equivalent to 5K rad per second. Our mega knot 1 over square root of LC equal to 4K rad per second. So our alpha is greater than omega naught, so our circuit is overdamped. We have our S1, S2 using the values of alpha and omega naught equal to negative 2K and negative 8K. So our VO of t just A e to the negative 2KT plus VE to the negative 8KT. This is volts. This is just the same expression as before. Solving for the values of A and B, we will get the same values. So our V of t is equivalent to negative 2 e to the negative 2kt plus 8 e to the negative 8kt. U of